In the last lesson, we had seen how do we do clustering using Rattle. Prior to that, we had seen how we would do the data ingest, right? After that, we had done something like the description of the data, or basically how do we look at the different statistics and parameters within the data. Post that, we also had a look at how would we transform the data, right? Then we did something around testing also, although very briefly. Then we went into clustering, wherein we are not trying to use something like a supervised model, but we were just trying to apply something like segmentation on an unsupervised learning method. Now what we will do is we'll go ahead and see how do we do basic modeling, right? To start off with, let me again start. So I'm just going to call the library Rattle so that we can load this. Okay, now we call Rattle. So there is no data right now. I'm doing it from the beginning again. So once the Rattle package is loaded, then we would go ahead and we would start off with the application. So here I have my Rattle application. Now I need to extract data. So now for the first part, what we will do is we'll just go ahead and select the library. So let me take the Boston dataset itself. Okay, so go down. So we need the mass package, and within the mass package we need the Boston dataset. Give mass. Should be somewhere around here. This is the only disadvantage of using the libraries within R through Rattle, that it doesn't allow you to search by typing the keywords. It becomes a little difficult. So it might happen that we have surpassed that data set and still we are searching. So maybe if we reach the end, then we'll think and we'll go back again towards the top direction. Mass housing, but this is a different data set, Copenhagen. So I guess we need to go a little bit up again to check. Boston. Yeah, you can use this because if you know the dataset name, that will come in a alphabetical order. So B is obviously here. Okay. Now, do we want a partition? No, we don't want a partition. So let's not take a partition of the data. Execute. By default, it does that. So I'll again remove this and execute it. Got the data in. Okay, now let's check the data. So we will have to make this as target input variable. Make MEDV as a target variable. Execute again. We are skipping explore, test, and transform, all these things as of now, and we're directly going to model. Okay, so by default, because it's a continuous data, tree, forest, linear, and neural net, these are the only options which are viable as per the GUI application. So let's click on linear because that is our intention. We want to create a linear regression model. Okay, and you have a GLM which is for your GLM model. We have a numeric one, so we'll select the LM and we'll just say and execute. So you'll see that the linear regression model and the output, you would have seen this when you have done this in base R also. So it has given you that output. So it has automatically done the modeling. You don't have to do anything. You can look at the ANOVA table, you can look at the regression table. Okay, you have the significance codes, everything is given here, right? Now, so the model building is already done, so you don't have to do anything, right? So just with a click you have created your model, right? Now the next part comes about evaluation of the model. So if I go into evaluate, I will have different things. So for example, I would want to check which one I want, right? So for example, the risk or the score, right? So you can select, say for example, this one, right? Or you want to see the predicted versus the observed, right? So when you click on whatever is activated, so if you click on risk, it describes the risk chart, provides you effective approach towards the performance of a model, right? So no harm in trying all of these things, right? So we don't have a validation data set and all those things, so we'll only have the training data set because we kept 506 observation all in one set, right? You could probably select an R data set also, okay? So it will run on the Boston data set, right? So now if you would have had training, validation, testing, and you wanted to build the model and test it on separately on validation, training and testing, and you wanted later on to actually do it on the R dataset, you could have done that also. Or if you have it in the local file as a CSV file, you could do that also. So maybe you can build the model on a separate set of data, separate file, and later on you can apply it on a different one, right? That is also possible. So you could do this, or when you change this, right, it will also give you these options. So it would give you a plot of predicted versus the actual model, right? Two lines also plotted, one being a linear fit to the actual and the other being the perfect fit, right? The R square is measured and all these things. You have already done all of these functionally. Score, right? So this tells you about the scores of the model. Now this might not be in line with the exact same parameters which you would have used, right? But you can try all of them. So let's say I want to do it with the risk. So I can just say execute. So it will give you a risk chart, right? Okay. It's truncated to a limited number of observations over here. So it's created the risk chart. On the other hand, if you want to go for the score, you can do that as well, right? So if you would have to do this, then you will have to create a separate file. It has given a name. You can override it and change the name if you want, right? So if I want, I can say Mohan underscore Boston train score indents. So I can have separate score files created for each of the data sets. Now say I want to save it somewhere, so I will say save it in the desktop, okay? Or say, yeah, I'll save it on the desktop and then I'll say save. Now I'm just going to minimize all the applications and just pick up the file in the hard disk. This is the output. So what it says is that this is the actual value of the data, that is MEDV, and what I am seeing over here is the predicted value. Okay, so there is a difference between the actual value and the predicted value, right? And that is your error. So obviously somewhere you would be very close to the actual value. Say for example, this one and this one is very close to the actual, well somewhere the difference might be quite huge, right? That's what you have observed before this also. Okay, and coming back to our application. So while you're doing this in the score, you could have done it only on the variable on which you want to do prediction, or else you can select all also. If you would select all, let's try that also. So what will happen is that the new file which you have created will have all the variables. So I'm just going to overwrite this same file so that I don't have unnecessary copies. And I can say, oh, let me first close this file. Is it closed? Yeah, it's closed. And then I can say save. Okay, now if I open that file again, Now let's check again. Okay, let's create a different file because I have used train all and this is indents. Okay, this file. So what will happen is it will keep all the variables along with the dependent variable and the predicted value, right? So again, if you need all the columns together as a file, then you need to use this. Now let's do one thing. Let's try to quickly get this file into your system just as a method. Like let me get a data. Right? So I want a data from a file, so I can just say file name, and I was on desktop, so say this is the data, right? The all one. Okay, so I can select this, just a CSV file. You have other options also, so if you want an Excel file, you can import that also, right? So this is CSV file I'm importing. Open, and I can say execute. Now it says that you already have a data file. Do you want to continue? It will overwrite the current project. I don't want to overwrite the current project, so I'm saying a no. Okay, in your case you can try that. Okay, you have in this separator option comma, semicolon. You can type that manually. You can selectively remove the headers if you want, right? So all of this is possible, right? Now coming back to the model, to the evaluate option. In the model also you have a plot option. So if you do that, you'll get these plots, right? The residual plots, the normality plot, QQ plot, right? Go back to evaluate, right? So we are done with the linear regression, right? You also got the prediction, so it's done. Now if you go into your log, you will see that the operations which you have been doing, right? So it creates a log of that, right? So if you see over here, it has built the linear regression model over here. If you can see, this is the print of ANOVA. So whatever you're doing, right, the charts, okay, all the logs are created over here, right? So this is also a good reference point for you. Okay, you can export the comments. You can do a lot of things over here, right? Obviously when you want to run it in R, you'll have to customize this code. You cannot run it as it is. Okay, now coming back to model. Now say for example I wanted to do a logistic regression model, right? But I don't have a class based data. MEDV is my variable of choice, right? So what will I do for that? That we will see in the next session.